Hello, this is 2.7, Parent Functions and Transformations. What are we going to do in this section? Well, let's look at our notes. We're going to identify and use parent functions, and we're going to describe transformations of functions from the parent function. Okay, so let's start with our vocabulary. There's lots of vocabulary. Some of this I want you to know, some of it's not that important. So the first one is family of graphs. So what it says, it's a group of graphs that display one or more similar characteristics. They're in the same family. Just like when you're brothers and sisters, you'll have some similar characteristics. What is a parent graph? It's the graph, the physical graph of a parent function. And a parent function is the simplest of the graphs in a family. Okay, this graph is transformed to create other members in a family of graphs. So basically, it's the equation. Okay, so what are the types? 1, 2, 3. We have 5 types of parent functions that we're going to learn. So let's just dive right into them. So these are the types of parent functions that we're going to learn. Constant function, identity function, quadratic function, absolute value function, and cubic function. So let's start with the first one. What is a constant function? So we look at the graph here. Oh, it timed me out again. So sorry about that. So a constant function is f of x equals a, where a is any number. And in a constant function, you're going to have the domain is all real numbers, and the range is going to be the value of a. And it's going to basically be a horizontal line, because what is f of a? So remember, f of a, f of x is simply a fancy way of writing y equals. So here is your constant. So it could be y equals 1, y equals 2, y equals 3. So remember, the graph of f of x equal a is just saying y equals a, where a is a constant, a number. So it's a horizontal line. So if y equals 4, y equals 2. So 1, 2, 3, 4. So y equals 4 is going to do this, and y equals 2 is going to do this at 2. Y equals negative 2 is going to be down here at negative 2. 2, 4. Okay, that is a constant function. So you need to know the domain is all real numbers and the range is just a. There's only one value. There's only one y value, right? No matter what x is, y is just, for instance, this one, it's y equals 4. The range is y equals 4. Right? What is the identity function? Another name for the identity function is the linear function. It is f of x equals x. It's a parent function of most linear functions because a horizontal and a vertical line, a horizontal line is a linear function. However, it has a different parent function than an oblique. Oblique is a slant. So it's basically the parent function of a slant line. The domain is all real numbers and the range is all real numbers. And it looks like this right here, this identity, this slanted line. And it goes through the origin. That's important to know. What is a quadratic function? So quadratic function is a parent function f of x equals x squared. It's a parabola or a U shape. The domain is going to be all real numbers. The range is going to be y greater than or equal to 0. Then we have the absolute value function right here. And it's going to, we already learned this, f of x equals the absolute value of x, where the domain is all real numbers and the range is greater than or equal to 0. There's one more that's not on our list. I'm going to draw it out for you. It's the cubic function, and I put a copy, a picture of what a cubic function is. It's on the last page. It's going to do this, except for they give you a really big definition. But the parent function is x cubed. They give you the function of a cubic function, but this is the parent function, which is the simplest form of the graph, goes through the origin and has a bend. The domain is going to be all reals, and the range is also going to be all real numbers. Okay, so that's the first thing we have to learn. So let's look at example 1 in our notes. And we need to find, they want us to identify the type of function represented by each group. So for A, it's a V-shaped, it's been transformed, so it's a type of absolute value. It's not the parent function, but it's a type of absolute value function. This is a constant function because it's a horizontal line. Remember, an oblique or a slant line is y equals x, or a identity function or a linear function. Okay, but this is called the constant function. So pause this and do guided practice 1A and 1B. All right, so now we're going to look at transformations. What is a transformation? So if you think back to geometry, you had 3 transformations. That means changes. You had a translation, you had a reflection, and you had a dilation. So we're going to learn what each one of those are. These are the 3 types of transformation. Know the difference. Sorry. Okay, so let's start with translation. What is a translation? That means you have a slide vertically up or down, and you have a slide left or right horizontally. So this is going to be when you have plus or minus k, and this is when you have plus or minus h. So what that says is when f of x, the function, whatever the function is, plus, and we use this because it's general, it applies to all of them. So whatever the function is, the parent function, plus or minus k, depending. So if it's a plus k, you're going to shift the function up. If it's a minus k, you're going to shift it or you're going to slide it down. Now, this right here is if you have f and you have inside the function x minus h. Okay, so remember it's x minus h. So this is technically written x minus h. Okay, so if h is positive, it'll say x minus h. That means h is greater than 0. If it says x plus h, it's going to be h is less than 0, which makes it negative. So if it's x minus h, that means h is greater than 0, it's going to shift to the right. If it's x plus h, that means x is negative or less than 0, you're going to shift it or slide it to the left. Okay, so then let's look at the example 2. So describe the transformation in y. So the parent function is the absolute value of x. Well, since we have plus 2, that's going to be f of x plus k. So 2 is k. Since k is positive, we're going to have a shift upward 2 units. All right, so pause this and do these 2. Guided practice A and B. So our next one is going to be reflection, is our next transformation. What is reflection? That's when it flips over a line, and that line is called the line of reflection. So line of reflection is a line that a particular graph flips over. We can either flip over the y-axis or we can flip over the x-axis. When we have that, so when we say when it's negative f of x, that means it's outside the function, then we have it flips over the x-axis When you remember, it flips up and down. The x-axis goes horizontally, but you flip over it, so you're flipping over vertically. And when you have f of negative x, then it flips over the y-axis, or it has a horizontal reflection. Horizontal. Because this is the y-axis, so if it flips horizontally, it's flipping over the y-axis. If it's flipping this way, then it's flipping over this line, which is the x-axis. So this is a vertical flip. This is a horizontal. You're thinking of a piece of paper flipping sideways, so it's over the y-axis and over the x-axis. All right, so let's look at the example 3. So example 3 says, describe the reflection in y equals negative x squared. Well, this negative, so our parent function is technically this. Remember, that says the same thing as this because there's nothing inside there. And so when it's just x by itself, we don't need to put the parentheses. So remember, this negative doesn't get squared, so technically it can be written like this. Since the negative is outside of the parent function, it's a vertical reflection, which means it reflects over the y-axis. So this would be a vertical reflection, not over the x-axis, excuse me. All right, so pause it and do guided practice 3A and 3B. Our last type of transformation is called a dilation. A dilation is going to be a shrink or an enlargement proportionally of a function. Or we can say it's a compression or a stretch. All right, so this one gets a little tricky when we're talking about a horizontal dilation. All right, so let's write this out. So if we have A times the function, then we have a vertical dilation. Okay? Now, if you take the absolute value of A and it's greater than 1, then you have a vertical stretch. If you take the absolute value of A and it's less than 1 but greater than 0, then you have a vertical compression or shrink. And they enlarge or shrink proportionally. I mean, they go out at the same rate. Okay, so that's a vertical. Now, what if you had a horizontal? Then that would be f of b times x. This would be a horizontal dilation. Okay, so these are dilations. Stretch or compression. Now, look at this carefully. So remember, it's inside, so I'll give you an example of what this looks like. So this would be 3x squared. Because that 3 is outside, doesn't get squared, so this would be A. Now this, let's learn what the stretch and compressions are. When the absolute value of B is greater than 1, you have a horizontal compression. Opposite. We'll learn later why. When you have the absolute value of B is less than 1 but greater than 0, you have a horizontal stretch. And what does an example of this looks like? What does it look like? Well, it's going to look like if I had 3x squared. That 3 is times the x, but it's inside the function. It takes on the square, correct? So therefore, it's a horizontal compression because the absolute value B is equal to 3, and the absolute value is greater than 1. So that's why it's a horizontal compression. Where this would be a vertical stretch because it's greater than 1, the absolute value. All right. So let's go ahead and look at the example. Example 4. Whoops. Sorry about that. So example 4 says describe the dilation in y equals 4x. So you have y equals 4x. Okay, that's, remember the parent function is y equals x. So this is times this. So we have a vertical stretch of 4. All right, so pause it and do the guided practice 4A and 4B. Now let's look at example 5, the real world problem. Now we're gonna put these all together. So it says Ethan is going to add a brick walkway around the perimeter of his vegetation garden. The area of the walkway can be represented by the function f of x equals 4 times x plus 2 plus 0.5 square minus 25. Describe the transformations in the function and then graph it. So let's start with the transformations. And so let's start with the equation. So f of x equals 4 times x plus 2.5 square minus 25. So the first thing you do is identify the parent function. The parent function is going to be f of x equals x squared because I have this whole thing squared. So now what do I have going on here? So let's look at the transformations. I'll have a that times x plus h, right, square minus k. So what is a? A is 4. H is, so remember this should be x minus negative 2.5. That's another way of writing this because the equation is x minus h. So h is negative 2.5 and k is negative 25. So A tells us we have a vertical stretch of 4. H tells us we slid to the right by 2.5 units. And K tells us we shifted down 25 units. So let's look at what our parent function looks like. So our parent functions always go through the origin, or most of the time. So the parabola does this. So I know we're going to shift it to the left. Let's just call this, I know it's not even, negative 2.5. So ignore my little things here. So it's going to go here, from here to here. And then it's going to go down to negative 25. So this is where the vertex is going to the left, because this is the vertex here. It's going to the left 2.5 and down 25. And then it's going to stretch, so it's going to go up. I'm just extending. We'll learn how to find exact values. But it's going to stretch, so it's going to get thinner because it's stretching up towards the y-axis. All right, so pause this and try example 25, guided practice 5. And you don't have to have exact values, but you need to know where this vertex is transforming to. All right, the last thing we have is I guess that's it. It's absolute value, and we did line of reflections. So stop the video and we'll see you in class.